So you've probably heard this term machine learning thrown around everywhere, right? But what does it, actually mean? Today, we're going to pull back the curtain and really get to the heart of this amazing technology.
It all boils down to one single, totally fascinating question. Can a computer genuinely learn on its own? Without a human having to write code for every single tiny decision it has to make. The answer to that is what machine learning is all about.
And that question takes us right to the classic definition, which came from a pioneer named Arthur Samuel way back in the 1950s. He called it the field that gives computers the ability to learn without being explicitly programmed.
That's a great definition, but let's be honest, it's a little abstract, right? So what does that actually look like in the real world? Well, to get it, we're going to go back to Arthur Samuel himself and this incredible checkers playing program he built.
Now here's the fun part. The guy who wrote the program, Arthur Samuel, well, he wasn't even that good at checkers himself. But he had this incredible idea. What if he could get a computer to teach itself how to become an absolute master of the game?
So how in the world did he pull this off? It was actually, kind of simple, but genius. First, he just let the program play against itself. Not once, not twice, but tens of thousands of times. As it played, it started to observe and recognize patterns, like which positions on the board usually led to a win and which ones almost always led to a loss. And from there, it just started building a strategy. Okay, I'm going to aim for these good spots and stay away from those bad ones. It was literally learning from pure experience.
And this is what's so amazing. Think about it. The computer, just by playing and playing and playing, got so much experience under its belt that it actually became a better checkers player than Arthur Samuel, the very person who built it. It learned beyond the skill of its own teacher.
Okay, so let me throw a question at you. What do you think would have happened if the computer only played, say, a couple hundred games instead of all those thousands? Would it have been better, worse, or about the same? Yep, if you guessed it would have been worse, you are spot on. And that really hits on the key takeaway here. More data, or in this case, more games, means more chances to learn. Simple as that. More experience equals better performance. Okay, so that checkers program was a fantastic example from the early days, but wow, has the field exploded since then. And today, even though there are a ton of different machine learning algorithms out there, they pretty much all fall into two main camps. All right, the first one, and by far the most common, is called supervised learning. The key word here is supervised. It's like you have a teacher or a supervisor showing the algorithm the right answers. Think of it like this. You feed it thousands of pictures, and you've already labeled them. This is a cat, this is a dog. The algorithm starts to see the patterns. So then, when you show it a brand new picture it's never seen before, it can make a really good guess. This is the magic behind stuff you use every day, like your email spam filter or image recognition. Then you've got the other path, unsupervised learning. And as the name suggests, there's no supervisor. You just give the algorithm a whole bunch of data with no labels and basically say, okay, go find something interesting in here. For instance, you could dump in all your customer data and it might find these natural groups or segments of people, patterns a human might have totally missed. It's awesome for things like market research. So now you know the two main styles, but here's the thing. Just knowing what they're called is kind of like knowing the names of the tools in a toolbox. That's a start, but it's only half the battle. The real skill, and really where projects succeed or fail, is knowing how and when to actually use them. Yeah, as the source material puts it beautifully, just giving someone a set of tools isn't enough. The wisdom is all in the application.
I love this analogy. It's like handing someone the most high-tech, fancy hammer you can imagine and just saying, all right, go build a 3-story house. I mean, come on, it just doesn't work that way, does it? You need the plan, the strategy, the know-how, the best practices to turn that tool into something amazing.
So let's talk about how the pros actually build these systems. And maybe we can start by looking at a super common mistake. And this isn't just a problem for beginners, by the way. I'm talking about really smart, experienced teams at major tech companies who can waste a ton of time if they don't get the approach right from the very beginning.
Seriously, it is not at all unusual for a team of brilliant engineers to spend 6 whole months grinding away on a machine learning project, only to get to the end and realize, oh no, we've been going in the completely wrong direction. And that is why understanding the how is just so important. When you know the best practices, you avoid all that wasted time and effort. You can use these powerful tools the way they're meant to be used. You start to see how the most skilled engineers get it right. It just gives your project a way better shot at actually succeeding.
Look, at the end of the day, the goal here isn't just to be able to define machine learning at a party.
It's to become one of those people, one of the rare people, who can really design and build serious, impactful systems that solve actual problems in the world.
So the question shifts, right? It's no longer what is this stuff? It's, okay, you have the tools. How are you going to start building?